All right, now let's spend a little bit of time talking about the major families that we're going to see in Myiasis. You've seen these families in other lectures, other lessons, but let's talk about their specific ability to cause this infestation of a living organism with maggots. So let's start out with the first, just the families. The major families we're going to see that cause myiasis are Californidae, Oostridae, and Sarcophagidae. So things that you've actually seen before. So they're the major producers of myiasis. Other fly families may produce myiasis, especially pseudomyiasis under certain circumstances, but by far it's these three families that we're going to see causing this infestation of a living organism. So, starting with Oostridae, as we talked about with this family, these are larvae that are involved in dermal, enteric, and nasopharyngeal myiasis primarily, mostly of animals though. Sometimes we do see it with humans. There are certain species that are human botflies. I can see this picture at the top here with a maggot being pulled from the dude's eye. Yeah, that's a human botfly. But we mostly see them involved in animals, and they can result in economic losses from animals, lowering in production, especially in cattle. We get weight loss, we get damage to hide, that sort of thing. So that tends to be when we run into botflies, is on animals and especially in production facilities. Californidae and Sarcophagidae, on the other hand, are usually attracted to wounds and sores of humans and domesticated animals. And in these cases, the larvae, in general, will feed on necrotic tissue. There are a few species, of course, that will feed on healthy flesh, but for the most part, these are necrotic tissue feeders. We can see some species that are accidentally ingested. They can invade wounds and cause severe discomfort and subsequent secondary infections, but that's not nearly as common. So we're going to go through all these families. I'm not going to spend any more time on Oostridae though. I already have that one video just talking about the major subfamilies. So that's really all you need to know. I do want you to know a little bit more about Californidae and Sarcophagidae in this context, however. So let's go over Californidae to begin with. These by far are the most likely candidates when we're talking about some sort of secondary myiasis. Just for the most part. So let's start with these major genera. So starting at the top there, this is Acromeromyia. These are actually blood-sucking larvae, and these form an atypical myiasis. These are interesting. The species do not live on or in the host in this case. So instead of penetrating a wound, they are going to suck the blood of sleeping animals. That's why they're commonly known as the African floor maggot. So these produce sanguinivorious myiasis. Remember the last lesson when I talked about all those different types of myiasis? So it is an obligatory or a primary myiasis producer, but it's not dermal. So they suck blood. All right, so up next is the genus Cortylobia. This includes several species of fly which prey upon specific animal species. So in these cases, the eggs are deposited on dry, shaded ground, especially if that ground is contaminated by urine or feces. And that just kind of makes sense if you think about it. There are common areas where animals will go to the latrine or use the latrine. And so those species that are attracted to urine and feces, they know that animals are coming back. Now, they also might deposit their eggs on drying laundry. So remember that really awful video I showed you of the myiasis of the breast with the timbu fly, that type of thing. So in these cases, the larvae will hatch in 1 to 3 days, and they remain just underneath the soil surface until they are activated by host body heat, especially when they are in the ground near latrines. So it's indicative of an animal has come to defecate or something like that. They're going to emerge and burrow into the host where they grow for about 8 to 15 days. So we see that. Now at the top here, this is the video of a picture of a dog with these maggots in the body, and what they do to remove them is just sort of pop them out like zits. It's gross and amazing. All right, Cochleomyia. Now we've already talked about these. So we got Cochleomyia omnivorax, Cochleomyia macellari, the primary and the secondary screwworms. So they produce primary and secondary myiasis, respectively. So Omnivore X produces primary myiasis. It's an obligate parasite of mammals. The females are going to lay their eggs at the edges of wounds or on mucous membranes of these living animals. And the larvae are going to hatch within about 24 hours. They're going to feed on the underlying healthy tissues and burrow into the flesh. This is where all that damage comes from. They're going to reach maturity about 5 to 7 days after hatching, and they're going to leave the wound by falling to the ground, and then they'll turn into pupae. The adults are going to emerge and mate within 1 to 3 days. Females will produce eggs about 4 days after mating and lay egg clutches of about 200 eggs all at once. The females will lay about 4 egg clutches over their lifetime, but they only mate once. So they are going to fertilize all those egg clutches from a single male. And that is one of the ways that we were able to eradicate them from the U.S. was because they are single mating. Okay. Now, Macellaria, they are secondary myiasis producers. They will feed at the edge or surface of a wound, and they are currently being investigated for maggot therapy reasons because they do not appear to feed on healthy tissue. The Chrysomya are also called screwworms under certain lexicon or in certain areas, but they can be known as the hairy maggot, blowfly, and things of that nature. Now, some species of Chrysomya only oviposit on live mammals. When they do that, they deposit 150 to upwards of 500 eggs at wound sites or body openings such as the ear, the nose, and the urogenital passages. The larvae are going to hatch 24 hours after they've been oviposited, and they're going to feed for 3 to 4 days. Now, these Chrysomya, especially Beziana, they do not appear to have any host specificity. So they've been recently recorded on 21 different host species at a zoo in Malaysia. So it does not look like they are really, really specific to a particular animal. Other Chrysomya species are facultative parasites, so they will normally lay their eggs on carcasses, but if there's a wound around, like a neglected wound, they are going to lay their eggs on that neglected wound, where the larvae will feed on necrotic and healthy tissues alike. Chrysomya rufacis, one of the hairy maggot blowfly that we looked at, causes this secondary myiasis most often in sheep, so it has been known as the sheep blowfly as well, although it has been reported doing myiasis on other animals and humans. Lucilia species. These species are responsible for a condition known as blowfly strike of sheep or sheep strike. Most commonly, it's Lucilia cuprina and Lucilia sericata. The females will lay their eggs on carcasses, in neglected wounds, and on the wool of sheep soiled with urine, feces, or blood, hence the name the sheep blowfly. Okay? One species of Lucilia is an obligate parasite of toads and frogs as well. So we do see a lot of myiasis, both primary and secondary, in Lucilia. Calliferous species. Both Califera vicinia and Califera vomitoria can cause secondary myiasis. Because both of these females, or both these flies, are attracted to any decaying matter, they usually end up on carrion, but they can end up on necrotic wounds. Now, there have been some reports that Califera vicinia may be a primary myiasis producer, but that has not been studied extensively, so we don't know for sure. Finally, Phormia regina. Once again, a carrion fly. We looked at this one, and it is attracted to festering wounds. It will infest necrotic tissue, and so it can cause secondary myiasis, especially on large mammals. All right, after all those gross pictures, here's an adorable kitten. Let me know if you have any questions, and up next we'll talk a little bit more about different species and different types of myiasis. Talk to you soon.